Hello everyone, welcome back to OrganiChemVerse. Today we are tackling an acid-base reaction. I know this molecule looks pretty complex for an acid-base reaction, but don't let that get to you. The trick is to just dive in. Once you start breaking it down, the answer will make sense. You will never get it if you don't try at all, isn't it? So go ahead and pause the video now to give it a shot on your own first. Ready? If you have solved the question, excellent. You can verify the answer at the end of the video. If you couldn't solve, just watch the video, learn from your mistakes, and then solve one more question given at the end of the video to master the concept. For the given molecule, you are supposed to find out the number of moles of water formed when this complex molecule reacts with sodium hydroxide. When sodium hydroxide is going to form water when it reacts with the acidic proton. So the OH and H is going to form the water. In what cases the sodium hydroxide is going to react? When the given functional group is acidic enough to react with sodium hydroxide, only then. Not all the functional groups given in the molecule will be acidic enough to react with the sodium hydroxide. Then, what sort of functional groups will react with the sodium hydroxide? When a functional group donates the proton and if it is stabilized by resonance, then it is considered as more acidic in nature. Sulfonic acid is going to react with sodium hydroxide to form the sodium salt of the sulfonate and water. Similarly, functional group like carboxylic acid, it's going to form water and carboxylate ion, and also phenol. When OH group is directly attached to the aromatic ring, then we consider this as phenol, and phenols are acidic enough to react with sodium hydroxide. Therefore, functional groups like sulfonic acid, carboxylic acid, and phenol easily reacts with sodium hydroxide. However, functional groups like alcohol. So why is this alcohol? Because the OH is not directly attached to benzene ring. In fact, it is attached to the benzylic carbon. So here we have a carbon, right? sp3 hybridized carbon. Hence, this is an alcohol. Since it is an alcohol, alcohols do not react with sodium hydroxide because they are not acidic enough. That means what? This bond is not so weak as compared to the sulfonic acid or carboxylic acid. Therefore, it will not react with the NaOH. No water is formed here. Although it can react with the stronger bases like sodium hydride or sodium. So these are considered as stronger bases. Only then it will react. So what do you understand from this? If the acid is strong, then it will react with the moderate base and then it will form the water. If the acid itself is weak, it will not react with the base like sodium hydroxide. We need a stronger base like sodium hydride or sodium. Therefore, you can eliminate alcohol here. Now, we have other functional groups like there is a phthalimide here. Although the sodium hydroxide might attack this amide, the product formed will not be water. Therefore, this is not an acid-base reaction. Similarly, for this amide also, it might act as a nucleophile but definitely not as a base. So, no water. This hydrogen here is acidic enough to react with the sodium hydroxide. Why so? Because once this proton is taken away, the formed anion, right, which is nothing but conjugate base, is stabilized by resonance from this amide carboxyl group and also this carboxyl group. Therefore, this is quite stable, which in turn makes this as acidic enough to react with the sodium hydroxide. So, What all functional groups are reacting here? Sulfonic acid 1, carboxylic acid 2, phenol 3, and the phthalimide hydrogen so 4. Not the alcohol, not the amides given here. So all put together, there will be 4 moles of water produced when the given complex molecule reacts with the excess sodium hydroxide. Thank you for watching this video and don't forget to solve the question given at the end of the video.